Okie doke. So, this is day 2. Let me get myself nice and comfortable. Hope you guys are comfortable working at home. Alright, you don't have to dress up so much. So, we're looking at number 6 in day 2. If you guys already haven't tried this one, alright, what you've realized is that this problem is a beast. Okay? It involves metric conversions, involves finding density, and it also involves finding the cost of aluminum per kilogram. Okay, so we're going to have to do a number of different things in this problem. Okay, so first thing is, let's read the problem. So it says new streetlights will be installed along a section of the highway. The posts for the streetlights will be 7.5 meters tall and made of aluminum. The city can choose to buy the posts shaped like cylinders or the posts shaped like rectangular prisms. The cylinder posts have a hollow core with aluminum 2.5 centimeters thick and an outer diameter of 53.4 centimeters. The rectangular prism posts have a hollow core with aluminum 2.5 centimeters thick and a square base that measures 40 centimeters on each side. The density of aluminum is 2.7 grams per centimeters cubed, and the cost of aluminum is 38 cents per kilogram. If all posts must be the same shape, which post design will cost the town less? How much money will be saved per streetlight post with the less expensive design? Okay, so number of different things going on here, okay? So let's talk about some of these things that these two posts have in common, okay? They're both going to be 7.5 meters tall, all right? And they're both going to be 2.5 centimeters thick, okay? Which means is that the aluminum is not going to be solid all the way through, all right? It's going to have a hollow core, right? But the aluminum on the outside will be 2.5 centimeters thick, okay? So that's what they have in common. Now, if you take a look at the density down here, okay? If you look, it's in grams per centimeters cubed. If you also look at our thickness, it's in centimeters cubed. But if you look at our how tall these posts are going to be, they got it in meters, okay? So my suggestion is the first thing I would do is to switch that to centimeters, okay? In order to do that, okay, I don't know if you guys remember this mnemonic, King Henry drank, in this case it's meters, so meters during council meetings, okay? So this is how you do metric conversions here. So right here is your kilogram, okay? Right here is your meter. Excuse me, I gotta sneeze. Whew. Okay, never mind. Okay, so that's your kilogram, kilometer. This is like your meter, your liter, your gram. Okay, and this is centimeter or centiliter. All right, and then this is milliliters. Okay, so milliliters, millimeters, milligrams, I guess, but we don't really use milligrams or centigrams, okay? It's usually kilograms or grams, but anyway, those are our metric, at least what we use the most. Kilograms, meters, liters, grams, centimeters, centiliters, millimeters. That's typically what we'll use, okay? So in this case, we're talking about meters, all right? So 7.5 meters falls right here, all right? And so the rule is, all right, you just take your decimal point, and since we're in the middle, it means we're going to go over. Let me get a different color pen here. We're starting right here. It means we're going to go over twice because we want to convert it to centimeters. Okay, so depending on what unit they give you, right, will fall on this chart here, and then you just adjust your decimal place to the left or to the right. So if they wanted it in kilometers, okay, we wouldn't move it to the right, we would move our decimal place to the left. Okay, but in this case we're moving it to the right, we're moving it 2 spaces. So 750 meters, or I'm sorry, 750 centimeters is actually 7.5 meters. Okay. Sorry, thought I had a sneeze coming. Woo! All right. So that is the height of our posts, of all our posts. Okay, 750 meters. All right, I'm going to get rid of this piece right here. Okay, just to kind of save room. All right, now let's talk about the rest of the problem here. Okay, so there's cylindrical posts and rectangular prism posts. Okay, so your posts are either going to look like this. Okay, or let's see if I can. I don't know if I'm going to be able to draw a rectangular post here, guys. So you're just going to have to bear with me. Okay, it's going to look something like this, all right? That's terrible, I know. But they're both going to be 750 centimeters. I'm sorry, this should be centimeters. Centimeters in height. All right? And so when we're talking about a hollow core, what this looks like, all right, so let me get a different color here. So for cylindrical post, okay, what's going to happen okay, not too bad. All right, is this pot in the middle is going to be 2.5 inches thick. Okay, and then for our rectangular prism, okay, this one's going to be 2.5 centimeters thick as well. Okay, so we're going to have to keep that in mind when we're finding these volumes of the cylinder and this rectangular prism, because what's going to happen is we're going to have to find the volume of the outside circle, find the volume of the inside circle, and then subtract in order to exclude these spaces in the middle. And so that is one lengthy part of this problem. Okay, so let's continue on here. So let's start with the volume of our cylinder. Okay, so the volume of a cylinder, scroll in here because I'm going to run out of room, is pi r squared times the height. Okay, so we need r squared. We're going to give us the height, and we all know what pi is, but we need to find what our radius is, so that we find that information right here. Okay, so our outside circle, okay, has an outer diameter. That's what it means by the outer diameter. All right, we're talking about the outer circle, the whole diameter of the whole post. Okay, it's 53.4. All right, in order to find the radius, we're going to have to go 53.4 divided by 2. And what does that give us? Where's my calculator? I thought I had it written down somewhere. I guess I didn't. 53.4 divided by 2. And you get 26.7 is the radius for our outer circle. All right? To find what our inner circle is, okay, let's not forget, all right, that this outer circle, okay, is going to be 5 centimeters thicker than the inner circle, right? Because if this is 2.5 here and this is 2.5 here, in order to find out what the radius is, I'm sorry, what the diameter is of that inner circle, we would just go 53.4 minus 5 is equal to 40 8.4. And then we divide that by 2. And we get 24.2. Okay? And that's the radius for our inner circle. So let me label that here. So this will be the outer, and this will be our inner. All right? And like I said, in order to find what these volumes are, we're going to have to do the outside. We're going to have to find the outside volume and subtract it from the inside volume. Okay. Pardon me, guys. I gotta go blow my nose here. Give me just a second. Okie doke. So, back to the problem at hand here. Okay. So, in order to find out what this volume is of the cylinder, all right, we have our radius. All right, so I'm going to find that right now. So I'm going to go volume of pi 26.7 squared times 750. Oops, oh, I made an error there. Give me just a second. 6.7 squared. Okay. And you should get 1,679,707.49. And this is centimeters, right? So centimeters cubed. Okay? So that's for our outer cylinder. Okay? For our inner cylinder, right, the volume is pi times 26, well not 26, 24.2 squared times 750. That's not what I got earlier. What in the world? Try this again. Second pi times 24.2 squared times 750. Huh. I'm not getting the same answer I got earlier. That's weird. Alright, so I'm just going to go 16,79707. Second answer. Yeah, okay. I'm sorry. I've had a brain fart. So, this is correct here. So you should have gotten 1,379,881.741 centimeters cubed. Okay? So, and then you're going to take this number here. I had a brain fart there, guys. I'm sorry. And you're going to subtract that number by that number right there. All right, I'm not going to write that all out, but when you subtract this number by that one below, you should get a volume 299,825.7488 centimeters cubed. Okay, so that is the volume of what do they call it? The cylindrical post. Cylindrical post. Okay? Alright. That one was the tough one. That one involves a little more extra work. Okay, this rectangular prism is a little easier to manage. So let's go back to this one. Okay? So, this one is, if you recall, has a square base that measures 40 centimeters on each side. Okay? So in order to find the volume of a rectangular prism, it's just length times width times height. So in this case, our length and our width is 40, and our height, don't forget, is 750 centimeters. Okay, so you can see why I changed that from meters to centimeters, because it just makes your calculations so much easier. Now you could obviously switch the other ones from centimeters to meters, but why would you want to do that? Okay, so the volume how many zeros? 1, 2, 3, 4, 5. Okay, so that's the volume of the outside. We got to subtract these middle pieces. So again, we're subtracting 2.5 from the whole piece. So our new square is going to be 35. And then this one's also 2.5 on each side. So now this length is now 35. Okay? So this, right now we're finding the volume of the inner rectangular prism. So it's going to be 35 times 35 times 750. And you get that number right there. Okay? In order to find what the volume is of this rectangular prism post, we would take this piece, we will subtract this piece here, and by doing so, oops, okay, so when you subtract that, you should get 281,250. So, the volume of this rectangular prism, this post, is that right there. Okay? Alright, so let's gather our answers here. So, I'm going to drag this down to the bottom. Whoops. 8150 centimeters cubed. Okay? And this is the volume of the rectangular prism post. Okay? Alright. So last part. We found the density. Now, if all posts must be made the same, which post will cost the town less? So clearly, it'll be the one that has the lowest volume. Okay? So as you can see, the volume of the rectangular prism post will probably be your best way to go here. This would be the it's got the smallest volume. Okay? So the church bells are ringing here. Come on. Alright. So in order to find which post will cost the town less, okay, we must figure out what is going to be the cost of each of these posts to make, right? And so the cost of aluminum is 38 cents per kilogram. Okay, so in order to find that, we need to find what the mass is of both of these things right here, because we got the volume, we have the density, okay, of these two posts, but we don't have the mass. And once we find the mass, then we can determine how much this is going to cost the town to make. Okay, so in order to find the mass, right, if you remember our triangle, MdV, right? So in order to find the mass, we gotta go density times volume. Okay, so we'll start with this one here. Not a room here, I guess. Not a whole lot of room here, guys. I apologize. Okay, let's start with this one right here. So, in order to find out what our mass is, okay, we need to convert this, or we need to multiply our volume times our density. So it's going to be centimeters cubed times our density, which is 2.7 grams per centimeters cubed. Okay, and as you can see, I put grams over centimeters cubed, because what happens here is when you multiply these two pieces, your centimeters will cancel, and then you're left with a mass, 299,825.7488 times 2.7. So you're left with a mass you're left with a mass of 809,529.5218 grams. Okay, but if you recall, our cost of aluminum is $38 per kilogram. Okay, which means we're going to have to convert this from grams to kilograms in order to find out what that price is. Okay, so let's think about this here. So we're going to go, this problem's a beast, I know. Okay, so in order to find out what this is going to be cost per grams, first we need to figure out, well, 1 kilogram is how many grams. Okay, so go back to your diagram here. King Henry drank Gatorade during council meetings. Okay, so 1 kilogram is actually 1, 2, right? We moved it over 2 spots. 1, 2, 3 is 1,000 grams. All right, and then this, the cost of this post is going to be $38 or 38 cents per kilogram. Okay, so as you can see, if you notice, I strategically set these things up all so that my units cancel, and we should be left with a dollar amount in all of this. Okay, so when all said and done, this will be left with, we should be just left with how much this is going to cost the town to make. It's going to be a dollar amount. Okay, so we're going to multiply this, we're going to divide it by this, and then we're going to again multiply it by 0.38. Okay, so let me write this all out here for you. So we're going to divide this by 1,000 and multiply it by 0.38. Phew! Bless me. All right. And so the cost, finally, of this cylindrical post for the town will come to $307.62. Okay, let's go over to the other side here. Make sure you got that in there. Okay, so to find the cost of aluminum for this rectangular prism post, all right, which we already know it should be smaller. Okay, it's got a smaller volume, so obviously the amount of cost, or the amount it's going to cost, is going to be a lot less, just because the volume is a lot smaller. Okay. That being said, also the reason for that is because the aluminum weighs the same in both. All right. So if the volume is a lot less in one, let's think about it, because how do we find the mass here? We have to multiply the volume by the density. Okay, so we're going to do the same process here. Right? In order to find out what our cost is per kilogram, we got to find the actual mass of this material. Okay, so 281,250 centimeters. Okay, times 2.7 grams per centimeters cubed. Right, again, right, if you notice, grams per centimeters cubed is written so that when we multiply these things out, your centimeters cubed cancels. You should be left with 759,375 grams. Okay, so that is the mass of our rectangular prism post. And finally, in order to find out what this costs, we first have to convert this from grams to kilograms. So I'm going to multiply, multiply 1 kilogram is equal to 1,000 grams. And the cost of this aluminum is 38 cents per kilogram. So again, our grams cancel, our kilograms cancel, and when you multiply all that out, alright, so when you multiply all that out, you should get 288.56 for the cost of this rectangular prism post. Okay, and finally, all right, in order to, so if all posts, which post cost will cost the town less, okay, obviously the rectangular prism post, so as you can see, all right, it definitely costs less, and then it wants to know how much less. All right, so you would go 307.62 minus 288.56. And you should get $19.06. Whew. Wow. What a problem, huh? Tell you what. Holy cow. Okay. So let me put some stars around here so you guys can, those of you that aren't using the videos, can know what our answers are. Okay, so this is our answer to that one. This is our answer to that one. Okay? Alright, hopefully that gave you guys a better instruction here. We haven't really encountered a problem that big. I know we haven't. As you can see, look at the amount of work we had to do to solve this one. So this is definitely one you may or may not, definitely one you may see, right? Because this is the type of density problem that the Regents likes to give because of all the extras you have to do here. There's metric conversions. You're finding the price of something. You had to find the density, or I'm sorry, you had to find the mass after given the density, to find the volume. A lot of stuff going on there. Okay? All right. Let's go to the next one here. So it says the height of a candle It's 13 centimeters, and the circumference of the candle at its widest measure is 31.416. Use modeling to approximate how much wax to the nearest cubic centimeter is needed to make this candle. Justify your answer. Okay, so this is number 7. All right, so put number 7 down there so people know where to look. Okay, so number 7. So how much wax to the nearest cubic centimeter is needed to make this candle? Okay, so when they say to the nearest cubic centimeter, okay, so they're talking centimeters cubed. This should already point you in the direction that we're trying to find volume. Okay, anytime you're trying to find a cubic unit of measure, okay, that involves volume. Okay, don't forget area is 2-dimensional, volume is 3-dimensional. Okay. All right. So let's talk about this. So they got a candle here. If you notice, looks like it's in the shape of a cone. Okay? It's in the shape of a cone. That's a crappy looking cone. A little better. All right. So let me zoom in here. So here's our cone. All right. It has a height of 13 centimeters. Okay. And it has a circumference at its widest measure of 31.416. So its circumference, okay, you got to remember, all right, it's the length around your circle. Okay, and as you can see, it's not in squares, all right, or it's not squared, right? It's just one single unit of measure. We're just measuring the outside of this circle. So if you recall, the area of a circle is pi r squared. Okay, but we don't want the area, we want the circumference. And the circumference of a circle is pi r times 2. Okay? Pi r times 2. Or, if you recall, the radius times 2 is just the diameter. So the diameter is twice the radius. So sometimes, depending on what kind of information they give you, will point you in the direction of what equation you want to use. Okay. All right. And also, to find the volume of a cube or of a cone, it's 1/3 pi r. Oh crap! Is it squared or cube? I can't remember. Gosh darn. Where did I put my notes? Sorry. Yeah, 1/3 pi r squared times your height. Okay, that's your volume of a cone. I apologize. I couldn't find my notes there for a second. Okay. So, being said, all right. So here's our volume, or here's our formula for the volume of the cone. We're going to end up using this one right here because we need the radius. All right. So we're going to have to divide by 2 anyway. So we might as well just do that right off the bat. So we're going to use this formula right here in order to find what our radius is. Once we find our radius, then we can plug it into the volume formula, and voila, we should get our answer. Okay? All right. So let's start with this equation right here. Okay, so our circumference is equal to that, pi r times 2. Right? And then we just solve for r. So I'm going to take 3.14, I'm going to divide it each side by 2 pi. So 31.416 divided by 2 pi Man, I'm just having some issues today. Oh, I didn't put it in parentheses. That's why. See? Didn't put this in parentheses in my calculator. Gave me a wrong answer. Just wondering what was going on there. So, our radius should be 5.00011,692. Okay? That's our exact radius. All right? And so in order to find the volume now, I'm going to take this piece right here. I'm going to plug it in for that radius right there. Okay, so when you do that, 1/3 times pi times second answer squared times our height. All right, now make sure, all right, it's in centimeters. Okay, we don't have to do any metric conversions here, but it never hurts to check. All right, sometimes they do that, though they might put that 13 meters, and so next thing you know, your calculations are wrong. So just make sure your units are lining up. All right, so in this case they are. Our height is 13 centimeters. So multiply that by 13, and you should get an answer 340.34 centimeters cubed. This is to the nearest cubic centimeter. So your final answer is 340 centimeters cubed. Okay? And that's your final answer. So let me put some stars around there so people know where to look. Okay? And that's the answer to number 7. Not as bad as number 6, I would say. Just a little tedious work in the sense that we had to find our radius given other formulas. Okay? But we got it. All right. Let's take a look at number 8. So a water cup in the shape of a cone has a height of 4 inches and a maximum diameter of 3 inches. What is the volume of the water in the cup to the nearest tenth of a cubic inch when the cup is half its height? All right? When the cup is filled up half its height. So that's going to play a part here. Okay? So let me draw my cone here. See if I can get a nice one. Okay, nice. Okay, well, good enough. So, actually that bugs me. I'll have a better one. So I'm going to draw a point right here. Here's my trick. Ah, pretty sharp. Okay. So, it says the water in the cup of the shape of a cone has a height of 4 inches, right, and a maximum diameter of 3 inches. Right, what is the volume of the water in the cup to the nearest tenth of a cubic inch when the cup is filled half its height? Okay, so here's a key part here, half its height. Right, so we only want our cup, we don't want it to go all the way to the top, we actually want it to only go half its height, which in this case is 2 inches. Scroll in here for you. Okay? So we're going to use the volume of a cone still. Okay? 1/3 pi r squared times the height. In this case, our radius. Don't forget, we're not going to use 3. This is the diameter. The diameter. Okay? So we're going to have to divide that in 2. So our radius is, 1.5. Right, so that's our radius. Our height is only 2. So we just plug that stuff in. didn't get all that. Let me try that again. I don't think I didn't use parentheses there. That's my fault. Pi is 2 squared Oh, good Lord. Did you guys see my mistake? Jeepers. Okay, let's try that again, huh? 1/3 times 7 pi. It's 1.5 squared times 2. There it is. Okay. And you should get an answer of 4.712. And there's our answer. Okay. All right. For some reason I feel like they might have gotten a different answer on that one. I'm not too sure though. No, that's about right. That's right. We're good. That's your answer to number 3. Or number 8. Okay, number 3. Number 9. Okay, number 9, number 10, and we'll call it a day. I don't think these last two problems are as hard as the other one. So a solid metal prism has a rectangular base with 4 sides, or with sides of 4 inches and 6 inches and a height of 4 inches. A hole in the shape of a cylinder with a radius of 1 is drilled to the entire length of the rectangular prism. What is the approximate volume of the remaining solid in cubic inches? So what's happening here is we're taking a drill and we're drilling out a hole 1 inch in diameter all the way through our rectangular prism. Okay, so first thing we have to do is we have to find the volume of this rectangular prism. Okay, which is you just multiply these 3 numbers together. Don't forget, it's length times width times height. Okay, so you just multiply those 3 numbers. And it doesn't really matter what order you multiply them in because multiplication is commutative. So when you multiply all that out, 4 times 4 times 6, you get 96, and this is inches cubed. All right, now we need to find the volume of the cylinder, which is pi r squared times the height. So in this case, pi r is 1 squared times our height, which in this case our height is this length right there, which is 6 inches. Okay, and so we multiply that out, you should get, well, 1 squared is just 1, so you're going to get 6 pi. Which is 18.849555592 inches cubed. Okay? In order to find our remaining volume, I'm going to take 96. I'm going to subtract 6 pi. And you should be left with 77.1504. All right, and this is what is the approximate volume, which means if you were to round it, okay, and clearly these aren't even close. So our answer is 77 cubic inches. Okay? All right. That is number 9. Number 10. Ooh, nice. A regular pyramid has a square base. Okay? Which means our base of our pyramid, no, that's not a very good square. Okay? It's going to have all the sides are going to be the same. Okay? Which is nice. Right? So the perimeter of the base is 36 inches. So they give us the perimeter. Now remember, the perimeter is the length of all these sides added up. Okay, so if our perimeter is 36, and this is a square base, means all the sides are equal. So you just go 36 divided by 4, and you get 9. Alright, so our sides of our rectangular prism, rectangular triangle, regular pyramid, okay, is 9. Right? And if you were to add all those up, 9 plus 9 plus 9 plus 9, we would get a perimeter of 36. So that's how I came up with that number. All right. What is the volume of the pyramid? Oh, and it gives us a height of 15 inches. Okay. So it's not going to be a very great pyramid. I don't even know if I can draw one. I'll try. Okay. Not very good. Right? But our height is 15 inches. So the volume of a regular pyramid is, 1/3 big B times the height. Okay. In this case, our big B, if you recall, big B stands for the area of the base. Okay? So in order to find the area of the base, we got to look at what our base looks like. In this case, our base is a square. And how do you find the area of a square? Well, it's base times height. So the area of this square is just 81 inches squared. Okay? 81 inches squared. Our height is 15, so now we just plug everything as is. So 1/3 times 81 times 15 you get an answer of 405 inches cubed. And do we see that answer? Absolutely. There it is. Okay? So, those last 4 weren't too bad. I think that first one probably definitely gave you guys some frits. So hopefully that guided you a little better on at least that problem right there. But as you can see, look at all that work involved there. We had to actually dip into the next problem. So if you had trouble with that one, that's okay. Just make sure you follow along and see what I did, and just let me know whether that makes sense or not. Okay? Feel free to email me anytime you guys want.